So, hello everyone. Hello Shubham. Okay, Shubham, I will be sharing the homework problems of the last 2 days after the stream ends. You can solve from tomorrow. Really, apology for the same. The important thing is to be consistent, and I really am very thankful to you for coming every day. Okay, so am I properly audible and visible? Can you all confirm, please? Hello, Shubham. Can you confirm the same? Let me just open the stream on my phone. Let me just open the stream on my phone. Yeah, okay, thank you. Hello, Abhinav. Hello, Yash. Hello, Din. So, should we wait for a few more minutes before we start so that other people can join? Hello, Adarsh. Hello, Naikaj. Are you here? Yeah, Shubham, I will be uploading the homework question. Really sorry about that. Hello, Naikaj. Yes, your attendance is marked. Thank you for coming. I see some of the names frequently. The students who are coming regularly, that include Naikaj, Adarsh, Shubham, Uddin. You guys are pretty much regular every day, and I really thank you for that. So let us start then. We have already 13 people with me. So let me share my screen and just give me a confirmation if it's properly visible. Hello, Mithilesh. Hello, Naikaj. Hello, Shubham. So let's start then. Yeah, you are here the first time. So basically, what we do here is that we come live at 10 p.m. daily, and we solve three problems related to data structures and algorithms. So, and right now we are at almost the end of this SD sheet streaming. We are on day 28. 2 more days are going to be followed. If you want to prepare for your interviews, then you can basically see the recording that are present on the GFG practice channel for the first 28 days. And we have been solving three problems daily, and we have also give three problems for homework. So there is a Discord channel in the description. You can join that channel and upload the pictures of your homework. Okay, did you get it, Mithilesh? So let's start then. So Abhinav, there is a question for you in the chat box. Shubham is asking when we will meet our course coupon. When you'll get your course coupon. I'm sure you will get it after the 30 days get over. Okay, so let's start without spending any more time. So I welcome you all to the day 28 of the SDE Sheet streaming. And my name is Gaurav Kumar Shah, and I'm presently in my third year BTech at IIT Kharagpur. So the agenda for today is that we will be discussing three problems as usual, and the topics for the three problem are the three topics are there. So first I will be discussing about the pre-order traversal of the tree. Then I will be discussing about level order traversal of tree, and the third problem would involve a dynamic programming approach to solving a Fibonacci number problem. Okay, so let's start. So did you all remember that I discussed in order traversal yesterday? I discussed the recursive as well as the iterative approach for in order traversal yesterday. How many were there? Did you all solve that problem after the stream ended? Okay, so today we will be discussing the level order as well as the pre-order traversal. Okay, so as I said yesterday, and I would like to repeat again that these traversal techniques are extremely important from interview points of view, and binary tree is also a very important topic, and these are very frequently asked. Okay, so today we will be only be discussing pre-order traversal. We will be discussing the iterative as well as the recursive approach. Okay, hello Naikaj, thank you. So after that, yeah, yeah. After that, I will be discussing about the Fibonacci number as well. Okay, so let's start. So let us start with the Fibonacci number problems. Okay, let me just close the problem. Okay, so the question basically says here is that given a positive integer n, we have to find the nth Fibonacci number. Since the answers can be very large, return the answer modulo 10 to the power 9 plus 7. Okay, so the expected time complexity to solve this problem is O of n, and we can also take a extra space complexity of big O of n. And the constraints are that n is from 1 to 1000. Okay, so basically, let's look into few important things before we discuss this concept. Okay, the first is that the numbers can be very large. Okay, that is why we have to take modulo 10 to the power 9 plus 7. Okay, apart from that, one more thing is that the value of n is equal to from 1 to 1000. Okay, so you know the how 1000th Fibonacci number will actually be very large. That is the reason we are taking 10 to the power 9 plus 7. It will overflow in the integer variable. Okay, so these two are important observations related to solving the problem. So let's come into the concepts. The first is the definition of Fibonacci numbers. So what exactly are Fibonacci numbers? I hope all of you know about this. Shubham is saying it's easy. Yes, Shubham, it's easy. So there is an algorithm called the matrix exponentiation using that can be calculate Fibonacci in O of log n. Yes, there exists, but we will not be discussing that. It may get a bit tough for other people. So we will be discussing a dynamic programming approach. Okay. So let's see what exactly is a Fibonacci number. So Fibonacci number is a special type of series. Okay, special series. Okay, how is it a series? So let's see. So the first two numbers of Fibonacci numbers are always fixed. So the first two numbers are 1 and 1. Okay, we all understood it. Now from the third number, the every number is basically the sum of its previous two number. So the third number would be 2. It is a sum of 1 plus 1. The fourth number would be the sum of 2 plus 1 equal to 3. The fifth number would be sum of 3 plus 2 is equal to 5, and so on. So this is how the sum of a Fibonacci numbers process progresses. Okay, so I have explained this concept yesterday in yesterday's stream, in which I discussed about finding n Fibonacci numbers up till n. So first n Fibonacci numbers. Okay, we could do it very easily yesterday. So let us look into it. So basically, every number is the sum of its previous two number. Okay. Now basically, how can we solve this problem? So let's say we have what can we do here is that try to implement a recursive function. Okay. Why a recursive function will be useful here? Because the concept that every number is the sum of its previous two number can be modeled in the form of a recurrence. Okay, so I can represent it in the function like this: f of n is equal to f of n minus 1 plus f of n minus 2. The only prerequisite for solving this equation is that I know what value is stored at f of n minus 1 and what is the answer for f of n minus 2. If I know these values, I can easily get f of n. And the starting values are always present because the starting values are 1 comma 1. That is, the first number is 1 and the second number is also 1. That is, f of 1 is equal to 1 and f of 2 is equal to 1. And for any n greater than or equal to 2, I will be using this expression. Okay, got it? Hmm. So Adarsh is saying next term is the sum of previous two terms. First two value is always one fixed. Now sum plus equal to ARR of I plus plus. Okay, crazy Varish. Okay, let's see how the problem gets solved. Hmm. So, so this is a recurrence relation that we are going to use to build our recursive function. No problem, Saivara. Basically, we are solving a Fibonacci number problem, a different problem than we discussed yesterday. So let's look into it. So let's say I get a function int f. It takes an argument int n. Okay. Now what will I do here is that I will keep an array. Okay. So this function will basically recursively call itself. So f of n. So if I want to, let's say I have a vector that will store the answer. Okay. Now basically, yeah. So basically what will I do here is that I want to recursively call this function of f of n minus 1 plus f of n minus 2. Okay, so these values will get stored in f of n, right? So how exactly this thing processes is something like this. Let's say I call for a function, let's say Fibonacci of 6. So 6 will try to call for Fibonacci of 5 and Fibonacci of 4. Okay, now 5 will again try to call Fibonacci of 4 and Fibonacci of 3. Now 4 will try to call Fibonacci of 3 and Fibonacci of 2. Okay, now this 4 will again call Fibonacci of 3 and Fibonacci of 2. 3 will call 2 and 1. This 3 will also call 2 and 1. This 2 will call 1. And 2 minus 1 is equal to 1. 2 minus 2 is equal to 0. But 0 is not there, so it won't call. Okay, and in fact, f of 2 is equal to 1. This will be my base case. Okay, so this will not call again. Okay, so did you all understand the recursion tree that I'm trying to say? Hmm. So this is basically the recursion tree that gets built up whenever we are trying to implement a recursive function to solve the Fibonacci number problem. Now, one thing that we are observing in this recursion tree, can anyone tell me what exactly we are observing in this recursion tree? Can anyone say what are we observing? Okay, see. So when if this function gets called with value 6, this will call these two functions. Okay. Now this function will call again these two functions. So let's say whenever one reaches the base problem, it returns a value. So value gets stored to this. A value will get stored to this. Okay. So what will happen? You see that f of 5 is being called twice, f of 4 is being called twice, f of 3 is getting called like 3 times. So why exactly is the need of calling a recursive function over and over again when what we can do is store the value of that recursive call in some place? Okay. So if f of 5 is being called once, I know the answer what will return because f of 5 will only have one answer. Okay. So there is no need to call it multiple times because doing multiple recursion, the time complexity becomes exponential and we don't want that. So that is why we are observing a very important property in this problem is the of overlapping subproblems. Okay, duplicate calculation. Yeah. So overlapping subproblems. So what property can we use now? Since we have overlapping subproblem, we can use the concept of dynamic programming. So dynamic programming says means we have to. So the basic concept of dynamic programming is that we remember certain values. Okay. So the if let's say that if we do not remember a certain value, we will be bound to repeat that calculation, and we want to avoid that. So that is the help of dynamic programming. We will remember that value. So any one time f of 5 gets called, I will store the answer of f of 5 in any data structure, and I will check that if f of 5 again needs to be called. Okay, if a situation arises in the program that f of 5 is getting called again, so I will check whether f of 5 exists or not. If it exists, then I will not call f of 5. If it doesn't exist, then only I will call. So before calling any recursive function, I will check that whether I have previously have this answer or not. If I have this answer, then I will not call. If I do not have, then I will call. Okay, we can store the value of overlapping problems. Yes, so that is the concept of solving the. I think recursive solution will also submit without DP. Okay, we will see. Let's see. You can see the constraints also. Basically, the constraints are n is equal to 1000. Okay, so basically, if you recursively call for everything, it will be a huge exponential time complexity. Okay, so let's see. Okay, so let us look into it. So how exactly are we going to do here is that we are going to create a DP table. Okay. In this DP table, we are going to record the values of all the numbers. Since n is equal to 1000, I will create a table of up to 1001. Okay. Now what will I do? I will create a function int f. Okay. This function will take a value n. Now what will I do? I will store the value dp of n is equal to dp of n minus 1 plus dp of n minus 2. And before this, I will check that whether dp of n is not equal to minus 1. If it is not equal to minus 1, it means that I have already gotten the value. So in that case, what will I do? I will return that value only. Okay, got it? This will not be dp of n, just a small error. This will be basically recursive function f. Okay, n minus 1, n minus 2. Okay, so this is how exactly the DP will proceed. So let's come to the coding part. Hmm. Yeah, and one more thing is that we have to take long, okay, because the thousandth Fibonacci number will be huge. So let's code. So, and in the question it is said that I have to return the answer modulo 10 to the power 9 plus 7. So in that case, what will I do basically is uh, let me declare int m is equal to 1 in 9 plus 7. Okay. So I will store in my DP table in such a way that they are always in less than 10 to the power 9 plus 7. So basically, I will take the mod and then store. So that is why I will declare a DP table of integer type. And let's say I declare it 1001. Okay. So this is my DP table. In fact, I should declare it outside. Okay, because DP will be a global variable because we will be doing a recursive calls. Got it. So let's see. Now I got a nth Fibonacci number. Now first thing that I need to do is memset the entire DP table with a value called -1. Okay, why -1? Because -1 is one of the values that we are not supposed to get anytime during the recursion. So, but if a value contains -1, it will be basically serving as a check that value is not computed. So we need to do the recursion. Okay, so DP. So we fill the DP table. Now the initial values, the constant values are the DP of 0 because the 0th Fibonacci number or the first Fibonacci number that will be at the 0th index is always 1. Now the second index, that is the first index, the Fibonacci number would be 1. Okay, we need to keep these two numbers. Okay, got it. Yeah, now I need to return a function. So let's say I create long int solve. Okay, so this will also take long int 10. Okay, now I will be calling dp of n is equal to solve of n minus 1 plus solve of n minus 2. Now these numbers can get very large, so that is the reason we will be taking mod m here and mod m here. And according to the properties of modulus m, I have to do a modulus to the entire thing also because after getting added, it may happen that it is overflowing integer. That is why I have to take a mod and then store it into my dp of n. Okay. Now before I also need to check that whether dp of so whether dp of n is not equal to -1. Okay, then we will return dp of n. Okay, now I will be calling solve return solve of n. Okay, and here also I need to return something, that is so did you all understood it, the concept of the code that I typed? Why do we need 1000 plus 1? Because you see that I need to store the thousandth number as well. So if I'm declaring a number by 1000, then the last index will be 999 and not 1000. 1000 will get a segmentation fault. Okay, so that is why we are declaring it one greater than the number we actually need. Okay, so let's submit this problem and check whether it's correct or not. Okay, so the code is not running for the first. Why exactly? The input was 10, the code output is 89, and okay, so what can be the mistake here? Can anyone point out? Yeah, now it will pass. So did you all know why exactly was that an error? Solve 3 questions from YT description. Today's all questions are easy peasy. Okay, Shubham, that's very well. Keep on solving all the questions and keep on practicing. Hmm. Okay, so do you have any doubt in this Fibonacci numbers? So basically, I did dp of 0 equal to 0 because let's say when the number reaches 2, I will be calling dp of 2 minus 1 equal to 1 and dp of 2 minus 2 equal to 0. So I did not specifically write dp of 2, so that is the reason I have to write dp of 0 and 1. So I can easily get the first number as well as the second number. Okay, So if it was 1, it will be definitely getting a number greater than the present nth number. Okay, start with 0. Yes, Shubham. Okay, so everyone understood it. There are no doubts. Then we can proceed to the next problem. Is everyone with me? We have 11 people with me right now. So let's proceed. Hmm. Okay, so let's proceed to the next problem. The next problem that we are going to discuss is the level order traversal. Okay, so how exactly level order traversal is, I will be discussing this. Hmm. Okay, so this is going to be a binary tree problem. So in a given binary tree, find its level order traversal. So the problem statement is pretty standard, and you do not need anything to solve this to understand this problem statement. Okay, so first we will look into what exactly are QBFS. Okay, Shubham, yes, we are applying the concept of depth first search using a data structure called Q. So first of all, what we need to do is learn about binary trees. So what are binary trees? Binary trees are basically a data structure of the type hierarchical. Okay, so these are hierarchical data structures. That is the reason these are very important data structures. Why hierarchy? Because we can represent data in the form of a hierarchy. So let's say what a binary tree. So binary trees always have a root. So root is the first node of a binary tree. After that, it has got its left child and right child. So this left child will also have its own child. This will also have its own child, and each of these are called nodes. Okay, and each node has a left pointer and a right pointer, and each node also has a value. Okay, so the characteristic of a node is that a node will contain a pointer to its left child, a pointer to its right child, and a integer value. Okay, so these are the data three components that can makes a node. So a node will only have two, left or right. So this will also may have left or right, may have left or right. So if any node that doesn't have a left or doesn't have a right, basically if they are null, then we call it a leaf node. Okay, and if it has something, then we do not call it a leaf node. It is a valid node. Okay, so this is the basically the definition of binary tree. Now we need to do level order traversal. Okay, level order means is that we have to traverse a tree in a level wise fashion. So let's say I'm drawing a tree 1, 2, 3, 4, 5, 6, and 7. This is a tree. So this is the first level, this is the second level, this is the third level. So when I'm asked to do a level order traversal, I will basically write all the levels, all the values of the level by level, and in the fashion from right to left. So I will write 1 first, then I will write 2, 3 first, then I will write 4, 5, 6, and 7. So this is the first level, this is the second level, and this is the third level. So this I will print in a data structure called vector. Okay, so this I will print in a vector. So this will be my level order traversal. So now how exactly are we going to solve? Now remember that in the function, in the problem statement, we are given to implement the function. Okay, so see that a function is given called level order, and we are only given the root, and we have to write a code that will basically print the level order traversal. Okay, so how exactly are we going to proceed? Any ideas, anyone? Shubham is saying QBFS. Yes, that is one reason. Any more ideas? Uh, can anyone say that since we discussed in-order traversal and we will also be discussing the pre-order traversal, can anyone say why cannot we apply a recursive solution to solve this level order traversal? Anyone? Okay. So basically, let's continue with the problem. I want you all to think about it and then type in the chat box. Okay. Because recursion will go in depth. Yes, Shubham, the idea is that the recursion always goes in depth and we do not want that. We want level wise level. So we have to use some certain other kind of algorithm that will help me traverse levelly in the level fashion. So let's look into that. Now, the data structure called queue. What happens in a queue is that whatever elements that goes inside a queue, let's say I am put this is a queue, and queue data structure is something like this. If I put one in the queue, then two, three, four. Okay, if one goes in the queue first, then two goes in the queue first, three, four, five. So one will come out first only. Okay, so it is kind of first in first out kind of data structure. Okay, so we are going to utilize this property of solving it. So how we are going to utilize it, let me see. Okay, so I am drawing it here only because I have drawn a tree here. So what we will do basically is something like this. Let's say I have a queue with me. Okay. Inside the queue, I put the root. That is one. Okay. After I put the root, then I will traverse on the queue. I will see how many elements are present in the queue. During the first iteration, I see only one element present, and that is my root. I will take the root out from the queue. Okay. After then, what will I do? After that, I will check it for its left and the right. So I see it contains 2 in its left and 3 in its right. So I will insert it in the queue, 2 and 3, and then I will remove this element. Okay, because I am done with this element, and I will print 1. After that, again I will traverse the queue. I will see that the first element is 2. Okay, because 2, since 2 went in early, so 2 will come out first. Okay, when we pop the node, we insert the child of this node. Yes, exactly. Okay, but we have to make sure that we are doing it for all the nodes in an iterative fashion. Okay, so now we take 2. Okay, so now we look what are the nodes of 2. 2 has 4, 5, 6. 2 has 4 and 5, and again 3. So basically 3 will have 6 and 7. So after this operation gets ended, in my queue I will have 4 elements: 4, 5, 6, and 7. Okay. Now again I will iterate over queue. I will check. Does 4 have any elements? No, 4 has null. So I will just remove the element and print 4. So 1, 2, 3 has already gotten printed. 4 has already gotten printed. Again 5, I will print 5. Again 6. Again 7. But since all the left and right child of all these nodes were null, so the queue is empty. So if at any point we find that the queue is empty, we will just break out of the while loop and we will return our answer because our level order traversal is done. Okay, so this is the concept of level order traversal, and this type of traversal techniques are solved using breadth first search algorithm. Okay, because breadth first search is basically a type of algorithm in which we visit a node, then check for its left and right. We traverse all its neighbors, then we look for other neighbor instead. Okay, that concept is done with the help of a queue data structure, and we will be applying similar concept to solve level order traversal. Okay, I hope everyone got it. Do you have any doubts? Okay, Shubham. Okay, Naikach, that's very well. So let's look into the coding part. Okay, so this is the next question. This was the coding part. Yeah, and one more thing that is important here is that let's start the code first, then we will discuss if we run into any issues. Okay, so the first thing that is here is that we have to declare a vector. Why vector? Because we want to store our answer, and let's call it answer. Okay, now the first check will be if root is equal to null or not. Okay, if root is equal to null or not. If it is null, then what should we do? We will do nothing. We will just return our answer. If root is null, it means that we will not have any traversal. Okay, because the binary tree doesn't exist. So this will be the very basic base case that we need to check. Now let's declare a queue data structure. So queue will be equal to node star because we will be storing node inside a queue. So the data type should be queue and not a values. Okay. So this will be equal to queue, and after that what we will do, we will push the initial element, that is the root. Okay. After that I will do while yeah. So the condition that we discussed was that the queue should never be empty. As long as the queue becomes empty, it is a signal that our traversal is done. So as long as queue is not empty, we will keep on moving in the loop. Okay. Then we will declare a temporary variable node star temp is equal to q dot front. Okay, why q dot front? Because the element that is going inside the queue first will be the first element to come out, and we are going to process that element only. Okay, so we'll take the front element of the queue. Okay, and we'll pop that element also. And after popping that element, we will check its left neighbor and the right neighbor and insert it in the queue. Okay, so now we will check if temp of left is not equal to null. Not equal to null means that there is a valid node in the left side. If there exists a valid node in the left side, we are just going to push inside our queue. So queue dot push will be temp of left. Similarly, we will do a right check as well. If temp of right is not equal to null. Okay, that is a right never exists. Then we'll push it temp of right. Okay, so this is done. After we are done, basically what we have to do here is that, yeah. So we also need to now push in the answer because we have processed the node that was in the front, that was q dot front, the temporary node in which we stored it. Now that node is processed, so that node is basically the answer of that particular level. So I will need to push that element into my answer because after process is done, because this becomes a part of my yeah, and I will be pushing the data. Okay, temp of data, because temporary is a node, data type node, and I want interested in the where the value only. After it gets over, my traversal is done, and after the loop gets over, I have my all my level order traversal in the data structure answer. So now I will return this. So let's submit this problem and check. As you can see, all the 130 test cases have passed, and we have successfully solved this problem. So any doubts? No. Hello Parthiv, welcome. Hello Uddin, hello Naikach. Yeah, okay. So everyone do not have any doubt. I hope everyone understood. Okay. So let me again repeat it that the traversal techniques are very important from interview point of view, and you should know the recursive part as well as the iterative part for all of the traversal techniques. Okay. So let's start with the first one. Okay, got it. Hmm. So we have 14 people with me right now. So let us continue. So the next problem that we are going to discuss is the can't we solve it without using temporary variable? Can't we solve it without using temporary variable? Just a minute. Ay, in some variable, then only I will process. Okay, right? Because you see, I need to access the front element. I can access by q dot front. Okay, let's say I do not put that in a temporary variable. In that case, what will I be doing? Is to doing something like this: q dot front of left is not equal to null. Then I will push it. After this gets operation, I will then pop out. Okay, so then it can be done in that fashion also. Okay, yeah, voice is breaking. Mm, is the voice okay? Yeah, basically what I was saying is that since I am popping the front element as soon as I put it in a temporary variable, that is the reason I am taking a temporary variable. But let's say if I do not take this variable, in that case I have to write q dot front here, I have to write q dot front here, and after that I have to push q dot front of data and then pop the element from the queue. Okay, so both will be doing the same thing. Okay, Siddharth is asking, कोड किस लैंग्वेज में लिख रहे हो? आई एम राइटिंग इन सी प्लस प्लस लैंग्वेज. Just a minute. Let me block this. Yeah. Okay, got it, Uddin. Um, Siddharth, I'm writing in C++ language. Hmm. So level order traversal is done. So now let's look into pre-order traversal. Okay. So what exactly is a pre-order traversal? Can anyone say? Definition क्या pre-order traversal का? पहले क्या visit करते हैं pre-order traversal में? Let's not look into the code. Node left right. Okay. Hmm. So basically we are given a binary tree. So as usual हम लोग को एक binary tree दे दिया गया and we have been given the root of the tree. Okay, we have to find its pre-order traversal. So let's say let's look into this example. 1 4, this is a 1 is a root. Its left child is 4, then its left child is 4 and it's 2. So first we will be printing the root. So if root हमेशा 1 होगा, so root will get printed. Then we will go to its left child. We come to 4. Okay, so since we are coming to 4, we print its 4. Then we again print the 4. and after that we print the 2. Okay, so it happens like that, root left and right. Similarly, something like this, first we'll print 6, then we go to its left and print 3, then we go to its left but there is no left, then so we go to its right, print 1, then we backtrack, so then the recursion basically backtracks and come to 2, and then after again 2. Excuse me. So this is how periodic traversal works. First is the root, then is the left, and then is the right. Okay, so let's say how exactly are we going to solve it. So what exactly can we do? We can have a recursive code as well. That is, write a function which takes the root, which takes a node. Basically, it will be the root. First of all, we will print the root. Okay, because we need to print. Then we will recursively call for the left part. Again, we will recursively call for the right part. Okay, and as soon as this root becomes basically null, we will return. Okay, so this recursive function will easily same. Okay. Hmm. Hmm. Is backtrack and recursion exact recursion? So recursion is basically calling a function again and again. Now, when do we use backtracking? We see that whenever we are into a recursive tree and we see that we cannot go any further, it means that if going any further will not lead to any result. So at that point of time, we stop the recursion and backtrack from that position. Okay, so that is the concept of backtracking. Okay, recursively call left and right, condition root to null, return and print root. Yes. Please enable subscribe strict mode so scammers cannot comment. Okay, no worries. I have just blocked the scammer, so it's okay. So let's look into it. Hmm. Okay, so this is a recursive implementation. Hmm. So now basically we will be having looking into the iterative implementation. Okay, so let's look into it. So how exactly are we going to solve iteratively? Any ideas, anyone? Any ideas? Okay, so using queue, no, exactly. Why do we need to use queue? Basically, the idea of using queue won't work because that type of operation is not needed actually. So basically, you see, I wrote a recursive function. What was happening in recursive function? We were printing it initially. So the first time, whenever we are reaching a root, we are printing it. After that, we are calling its left and we are calling its right. Okay. So basically, we know that in a recursion, what happens is that we have to use a recursive stack space. So whenever we are calling the left part, it stores the left part. Then again, it keeps on calling the recursive function. So this recursion stack space, this concept of recursion stack space need to be implemented externally in the form of any data structure. Okay. So that is why the reason we are going to use stack data structure. Okay, to make the code from recursion to iteration, we are going to use stack data structure. Everyone knows the stack data structure. Whatever goes in first will come out last. Okay, it is a type of LIFO type of data structure. LIFO, last in first out. Okay, so whatever element goes in the stack, the last will come into fast. And exactly this type of implementation is needed to solve this problem. So what exactly are we going to do? We are going to declare a stack S. Got it? Yeah, using stack, yes. LIFO. Yes, so then we will be using stack. Yes, Adarsh and Sachin, yes, we will be using stack. So let's see how. So we have to declare a stack. And what we are going to store in the stack, we are going to store the address of all of our nodes. Now what do we will do? The first thing is that inside my stack, I will push the root element. So let's say I have a binary tree, something like this. Okay, this is 1, this is 2, this is 3, this is 4, this is 5. I will push 1 into my stack. My stack is done. After that, initially I will put. Now I will run a while loop. And the condition of the while loop will be as long as the stack is not empty. If my stack is empty, it means that traversal is over and I will print it. Okay. So basically what will I see? The last element that I inserted into my node should be checked now. So I will take this st.top, the top element present in the stack. That will be the last element inserted. In this case, it's only one. After that, what will I do? I will just push into my answer vector, answer or pushback, the top element. I will push into my answer vector because that is what we were doing. Whenever we are visiting any node, first of all, we are printing it. And after that, we are going to visit its left and then its right. Okay. Now what will I do? Now you see that we need to visit left first and then right. Okay. But if we insert left first and then right, so basically right will come out first. So right will get printed. So we don't want that. We want to print the left first. So basically, since we want to print the left first, we will be inserting left up second, and we will be inserting right first. Okay, because whatever we will insert last will come out first. That is the reason we will be inserting right first and then left, so that we can have left printed first and then the right. Did anyone understood this very important concept? Why we will insert right first and then left? Do you have any doubt there? So I can explain once again. Okay, I hope everyone understood it. Chalo. So let me repeat it once again. Since in the this pre-ordered traversal, we need first left and then right. But in stack, whatever goes in last will come out first. So since we need to print out left first, we will be inserting left at the last. Okay. So we will be inserting the right first and then the left. And after that, this whole while loop gets over, we will return pre-order. Okay. I hope everyone got it. So let's come to the coding part. Great. Okay. So let's come to the coding part of solving this. So basically, as I just said, first I will be declaring vector answer. First I will be declaring a vector answer, and the vector will be int. Okay. Now after this gets done, the first and the very basic condition basically is that I need to check whether my current is null or not. If it is null, it means that I do not have any binary tree in place. So basically, I will return an empty vector as an answer. Okay, so I will just return answer. After this is done, I will declare a stack as I explained. But this stack will be of data type node star because I will be putting up the addresses of my node. Okay, so let's say I call the stack as. Now I need to insert my root into the stack. So I will just push my current CURR into my stack. This is done. After this, I will run a while loop. Okay, so this while loop will basically contain this s.empty. So if stack is not empty, as long as stack is not empty, I will keep on iterating. Okay. So what should I do now? As I said, the first thing that we have to do is print it. So before we print, we have to take a temporary variable node start temp, in which I will store the st.top. Okay. I took the top element and store it into my temporary variable temp. Now what will I do? I will in my answer variable, I will just push back this value. Okay. I will push back this value, answer or pushback, and this will be equal to temp of data. Okay, I need to store the integer data. And after this is done, I will just pop the element. Okay, because I have already processed that element and there is no need to go again. Now what will I do? I will check if the right node exists or not. If temp of right is not equal to null. If it is not equal to null, in that case, what will I do? I will push it into my stack because the right part exists. Okay, so in that case, what will I do? Temp of right, it is done. Now if temp of left is not equal to null again, in that case, what will I do? X dot push temp of left. Okay, this is done. After that, basically after this while loop gets over, I will just return my answer. Okay, so let's submit this code and see whether it is correct or not. So there is a compilation error. It says st.tab doesn't exist. So because I declared it in S, so let's write S. It's not st. Yeah. So as you can see, all the 310 cases have passed, and we have successfully solved this problem. Okay. So we are done with all the three problems. So do you have any doubts? We have 16 people with me. So did you all enjoy this session? Did you all understood what exactly both concept that I discussed today? Great. So I would request everyone, the 17 people present here, to like this live streaming. Okay, I can see only 3 people have liked it till now. Can you all just like this live stream? It's a great request. Okay, yes, Satyendra. No doubt, great session. Thank you, Naikaj. Time complexity, great. Okay, so you want me to discuss the time complexity? Okay, so time complexity will be basically O of n because we are doing an iterative traversal. Let me just open this. So, yeah, since we are doing an iterative traversal, which requires basically visiting all the nodes of my tree, and there are n nodes in my tree, and basically the number of nodes will be 10 to the power 4. So that is why the time complexity is linear, big O of n, and we are taking a stack also. So in the worst case, what can happen? The stack will contain all the n elements. So in that case, the auxiliary space complexity is big O of n. Okay. Gaurav, you are from third year. May I know when you started DSA and where you learned? Okay, so basically, I'm in my third year. I started my DSA during the winter vacation of my second year. Okay, that is in the month of December last year, and it took me around like 4 to 5 months to become very proficient in data structures, algorithms, and competitive programming, so that I can clear the interviews and tests. Okay, so, Alpha Gaming is saying, what do we have to do to start learning DSA? The first thing that you need to do is pick up a programming language. That would be C++. I would recommend to start C++. And after you learn C++, you can learn the standard template library of C++. That is very helpful to solve DSA problems. After you do that, then you can start learning the problem solving techniques. You can learn the greedy algorithms. You can learn about bit manipulation. You can learn about arrays. You can learn about other things in the starting part. You can learn about the maths required for DSA. After that, you can go to dynamic programming. Well, you can learn about iterative, then recursive. After that, you can learn about graph traversals. Okay, so this will take around like 4 to 5 months to get very proficient in. I started CP with Python and don't have much idea on CPP. Can I continue DSA in Python? No, I won't recommend you do that. I will recommend you do in C++ only. Okay, sir, can I start in first year? Yes, you can start in first year, but it is recommended that you start in second year. Like, but you can definitely start in first year. If you start early, you will become very good early also. That's depend on you. You can start from first year. Okay, okay. So, so can you please solve today's lead code contest second question? Okay, this is a streaming for SDE sheet solving on GFG practice channel. So I will stick to that only. Any more questions? So that's very great. I'm in first sem. I have started DSM. Okay, that's very good, Naikos. Keep practicing daily. Solve at least 3 to 4 problems daily, and keep on revising of what you're doing. And I would also recommend you to start competitive programming on Codeshift and Codeforces. In that case, you will become good at problem solving. Which platform to follow for DSA? The Geeks for Geeks platform is excellent for following the data structure algorithm. You can check out its courses as well. And apart from that, it contains great blogs written by very talented people. And you also have a dedicated practice section also on Geeks for Geeks. So basically, you can solve all standard problems on data structure and algorithm on the GFG platform itself. Okay, you will also find editorials there, video editorials, and articles written. That will be very helpful. Okay, okay then. We have reached to the end of the session. This is the day 28, and from next day onwards, tomorrow will be day 29, and tomorrow I won't be streaming. Okay, so have a nice weekend, and thank you very much for listening to me, for joining the session. Can you all like, please? There are 3 likes only. I would request you all to like the stream. चलो चलो like कर दो. I can only see 3 likes till now. Please like it. Good night. Good night, Naikaj. You can also subscribe to the GFG channel, and we have this session daily at 10 p.m. So you can join. Done already. Okay, okay, no worries. Thank you, Ankur. I have already liked. Meet you next time. Good night. Okay, thank. Good night, Saivara. Okay, so we got 22 likes. That's very very great. Chalo. And I would request all of you all to kindly share the GFG channel and this streaming to your friends at college. So basically, everyone can know about this channel and the content over it. We have basically a lot of videos and content related to practicing DSA problems. And okay, then that's it. Goodbye, everyone. Have a nice weekend and good night. Yes, bye bye.